In this video, we're going to look at problems with a DC motor. Okay, so let's set up a scenario where we've got an armature consisting of 200 turns which has a current of 0.5 amps running through it, a magnet with field strength 4 Tesla, and the current's flowing conventionally from positive to negative. We're going to determine the direction of the armature's rotation and explain why this happens using this diagram. Now the armature is 12 centimeters by 6 centimeters across. Okay, and we've got north and south. Alright, so we know that the current is flowing conventionally, so we're going from positive to negative. So I use my thumb to show the direction at point A and my fingers to show the magnetic field. As a result, it's pushing down on A and pushing up on B. So at point A, as we've stated, because the current is going up and my fingers are going from left to right, the force above the wire is going to be greater than the force below the wire, because it's constructive above and destructive below. At point B, we're going to get the opposite because the current is going in the opposite direction. Thumb going down, fingers going left to right, below the wire is going to be greater than the force above. Obviously, the result is it's going to spin anti-clockwise or from right to left from an area where there's strong to weak. Okay, let's look at question B. So in question B, using the same thing, we're going to calculate the force, the magnetic force, which is applied on wire A and B. Now the first thing we need to know is that the current in both A and B are identical. Also, the magnetic field is also identical. So therefore, the force is going to be constant on both sides. So let's see how we can solve this problem. Alright, so let's write down what we know. Well, we know that the field strength is 4 Tesla, and we've got that from the question. We know that the current is 0.5 amps, again from the question. We know the length of the wire, which is in contact with the north and south, is 12 centimeters. That 6 centimeters is running perpendicular, so it doesn't count. So we only use the 12 centimeters. And we have to convert it into meters, so it's 0.12 meters. However, that's not all the length because we've got 200 turns. So that means we've got 200 lots of 0.12 meters acting. So let's use Fibble, or force equals field strength times current times length. So it's 4 times 0.5 times 0.12 times 200. Remembering 0.12 times 200 is the total length. And we end up with 48 newtons, which is acting downwards on wire B and is acting upwards on wire B. Okay, so let's look at question C. So in this case, we've got the same situation, but wire B is going to move from its current position, which is on the right-hand side, through 197 degrees. And we're going to determine what the force is going to be on that portion of the wire at this point. Okay, so let's look at the solution for this. Okay, the first thing to understand is this is the position that B's at. Okay, and it's going to move through 180 degrees, which is going to take it to the other side. But we're not asked for 180 degrees, we're asked for 197. That means it moves to this dark position here, this line here, which is 17 degrees below that horizontal point. Now at vertical, we know that F equals 0, and at horizontal, F is maximum. So basically, at the point that full line is, it's going to be 17 degrees less than maximum force, which is acting on the wire. So 90 minus 17 gives me 73 degrees. So if I substitute that in for theta, that will allow me to calculate the force. So I can use F equals BIL sine theta, where theta will be 73 degrees. Now I know what B is because I got that in the question, which is 4 Tesla. I is going to be 0.5 amps because that hasn't changed, and the length is going to be 0.12 times 200 again. However, I could also use the answer from A, which is BIL came out at 48 newtons. So I could just substitute 48 newtons into the equation and multiply it by sine theta. But let's do the first one first. So I've got 4 times 0.5 times 0.12 times 200 times sine 73. Or I can add in BIL equals 48 times sine 73. And the answer comes out looking at 45.9 newtons, and it will be acting in a downwards direction. Notice it's less than the maximum force of 48. Thanks for watching.